Okay, there we go. All right, welcome to Effortless Distributed Systems with .NET Aspire. Hi, I'm Jason Taylor. I'm a Microsoft MVP in Developer Technologies, and I'm also a solutions architect for Particular Software, which is the team behind N-Service Bus. We help developers build reliable, scalable, and maintainable distributed systems. Now, distributed systems are everywhere, and if, like most developers, you feel that's a little bit hard, you're not alone. And that's why we're here today. So my goal is to show you how, with the right tools, you can make that distributed systems development a little bit less difficult, a little bit less stressful. You can remove some of the friction, so to make it feel effortless. So let's begin by defining what a distributed system is. So a distributed system is a system of multiple services or components working together. And those services are running on different machines. So you can think servers, containers, or cloud resources. And they communicate over a network and behave as one single application. Here's a simple but common distributed system that you might be familiar with. We've got a web front end, an API backend, and a database. So you can see this is quite simple. Just because it's a distributed system doesn't mean that it has to be a full-blown microservices deployment. If the database is running on a separate server, then you have a distributed system. You'll need to communicate across the network. So whether your system looks small like this or is growing into something larger and more complex, the challenges are the same. These include orchestration, service discovery, reliability, observability, and configuration. And so these challenges are exactly what we aim to simplify with effortless distributed systems. So effortless distributed systems shifts the focus back to what matters. And of course, we know that that is delivering features to users, things that users care about. We want to reduce wasted effort by eliminating manual setup, wiring, plumbing, and boilerplate. And we want to simplify the hard things so that teams can move faster and with greater confidence. Now, effortless doesn't mean no effort. It means reducing friction and focusing our effort on those things that matter. To make this possible, we need a solid foundation. You may already have your foundation. You've looked at your local dev to cloud story, and you've removed all of the friction possible, and you've found a smooth pathway. And now you're just focusing on what matters. But if you haven't found this pathway, this is exactly where .NET Aspire can help. So with .NET Aspire, it simplifies distributed systems from the start. It's a framework that gives us tools, templates, and packages for building distributed apps. At its core, it contains a code-first app model, which acts as a single source of truth for our services, our resources, and the way that they connect. So think of that simple distributed application that we looked at before. We had a web front end, we had an API backend, those are our services. The resources were the database that was sitting behind the scene. How they connect, the connection strings, the configuration across environments, these are the things that we're looking at. It also provides pre-built integrations for common infrastructure like messaging, databases, caching, and hosting. And most importantly, Aspire is designed to work from end to end. So from your local development environment all the way through to a deployment in the cloud. So let's see .NET Aspire in action. We'll add Aspire to an existing app so you can just see just how quickly it can simplify distributed systems development. So this is an application you've no doubt seen before, but I don't want you to worry. This is not a Hello World application. It also has a counter, so we can count things if it's running. One thing I should mention about this application is it's not just out of the box. I've actually made it a little bit less reliable. About 30% of the calls to the API backend are going to fail. So I can count things, and a lot of the time I can get a weather forecast, but not always. But that's okay. Our customers can just retry. They're really good at pressing F5. they can press F5. Some of the smart ones know how to press Control F5 to do a nice hard refresh. But you know what? I've actually forgotten to start the API backend. That's one of the difficult things that we face as developers, launching multiple projects. So I'm going to start the API backend as well without debugging. We'll save that for later. And now we should be right 70% of the time. So no, of course I didn't just give you a file new project, I made it worse. But don't worry, I put a bug report feature in so that we can start to report these issues. So 70% of the time, that's right, these issues will be reported 70% of the time. Now, I didn't have time to build a lot of features, so they are going to a database, but no one's ever going to look at them because there's no feature for that yet. So, but it's a good start, okay? So we've got a weather forecast and a bug report, and it's not reliable, right? I've got some books over there to share with you, Fallacies of Distributed Computing. The first fallacy is the network is reliable. Well, I'm not running across a network yet, so I've got a little bit of chaos in here so that we can address that. So let's stop that for a moment, and let's see how we can bring Aspire into this project. So I've got my API backend. I'm just going to zoom in on that, and I'm going to right click and go add .NET Aspire Orchestrator support. And you can see over here it says this is going to add 2 new projects to your solution. We'll have an app host, which is going to be responsible for modeling our application, right? The services and the resources that our application will use. And we'll have service defaults, which will bring in all of the smart defaults that we should have in our application. So logging and open telemetry and health checks and those sort of things. It's going to bring those in for us. So let's go ahead and add that. And we're going to do the same thing for our web project. And so I right click again, add .NET Aspire Orchestrator support, okay. And we can have a look at app host now, right? So here's our app host project, and here's the app host file. And this is describing our application. There's not much to it at the moment. We've got a project called API service. Thank you. And we'll just simplify the name a bit. So we can refer to this name later on, you'll see how. And we've got a project called web. And so I haven't done much here, right? We've just added Aspire Orchestrator support. I'm going to press F5, and let's see what happens now when we start our application. I've got a little console window in the back end here, and it's firing up this Aspire dashboard. And this is really cool because it's not just a dashboard. In the background, it's also started up our API service and our web. So now I don't need to start up those projects separately. These things are being orchestrated. They're being coordinated by .NET Aspire. And if I want to, I can look at the console logs for what's happening behind the scenes in the API service, so I don't have to jump around with lots of console windows now. And there's web, it's sitting there listening away. And if I want, I can go to resources and I can launch the application. And I can do all the things I did before. I can count things, as many as I like. I can get the weather forecast and the weather.
70% of the time.
Say?
Still 70% of the time.
70% of the time. But you know, if I refresh this, what's happening here? Look, there's a little glitch there. But it still worked, another glitch. So all I did was add .NET Aspire orchestration support, and this system has become more reliable. Why is that? What's happened? Let's have a look behind the scenes. So when I added the orchestration support, it added in some of those smart defaults that we talked about. And if we want to see the smart defaults, we can go to this project, service defaults and extensions, okay? And if we zoom back out, bring this in, we have add service defaults. And this is actually being called when the web project is being wired up and when the API service is being wired up. And so it's configuring open telemetry It's configuring health checks. It's adding service discovery. We're going to look at that right now. It's configuring some HTTP client defaults, which includes adding a standard resilience handler using Poly. So it's using a package called Poly to retry these requests to the API when it fails. So that means that, most of the time it'll retry and retry until it gets that weather forecast, because the network is not reliable. Okay, these are things that we know, that we've known for quite some time now, but a lot of us still aren't bringing them into our application. And so with .NET Aspire, we get these smart defaults. We can just say, add service defaults, and they come in. Okay, we'll use that a little bit later as well. But first I want to focus on app host, and I want to see some things that we can do here. We can orchestrate things, right? So let's give these variable names. So we'll call this one API service, and we'll call this one web. And I can say, you know what? The web service is no good without an API backend. So why don't you wait for the API service to start before you start, okay? And what's more, we want to say with reference. And this is really cool. So what this is doing, as you can see, it's injecting service discovery information into our web project. And what that means is that if we go over to, might turn the volume down there, just a touch. So if we go over to, that's not what I want, program.cs in web, you can see there's service defaults, right? Add service defaults. And here we've got this hard-coded URL to our API service. But I've just said we can use service discovery, and what that means is we can instead use HTTPS preferably, or fall back to HTTP, and instead of a hard-coded URL, we can just reference the service name, API service, okay? And I'll show you how that works in a moment. But what that means is that that magic string does not need to change between environments now. So we had it hard-coded, it was no good. Now it's a service discovery string, something that the service discovery feature understands. So why don't I launch it again, and let's see. I'll try to launch it. Why won't you launch? It's already running. Okay. Launch it again, and let's see the dashboard come up. Okay, you probably didn't see it there, but there was a little second where web didn't start. It was just waiting for the API service to start. Now if we have a look at web here, and we just scroll down to its environment variables, scrolling. Okay, look at this. We've got services, API service, and if I click on this, this is the HTTP one, and this is the HTTPS one. So it's using environment variables now to wire up the front end to the back end. So we don't have that hard-coded. And so when we go from local development to production, we're simply setting environment variables in our production system. We don't need to change anything in code. All right, let's have a bit of a peek around here. So you can see we've got our resources, we've got a list of resources, we've got a graph if we like that sort of thing. You can see that web is dependent on service, and we can jiggle it around and watch it. That'll grow a lot as we do this presentation. We can see all of the output that's coming in the console, and man, they've tidied that up in 9.5. I haven't had time to look at what's changed in 9.5 yet, but these little tags here, that's looking really cool. We've got structured logging, we've got traces, and we've got metrics all out of the box, right? We don't have to wire this up as we go. This is now available for us. So if we go to web, what about these structured logs actually? Let's see here. So if I put it on web, are there any failures there? Let me zoom out. Let's see if we can get a failure going. One, just a few refreshes. think that is one. Okay, good. So we had these warnings here, and we can kind of dive in and try to understand what went wrong. We can have a look at the stack trace and all the stuff we used to, or we can just click on GitHub Copilot. And we can just wait a little bit, and then we can click on this, investigate log 32, right? And it's going to just spit out a wall of text. It's going to tell us everything that went wrong. It's like, can you say that again, but pretend I'm only 5. Really dumb it down. The part of the app called web tried to ask another part of the app called API service for the weather, but something went wrong. The helper in your app called Polly noticed the problem and said, let's try again. So your app didn't stop working. That is much better, right? Now we understand exactly why. We don't even need to read that. It was too verbose. So that's a really cool feature, right? I like that. All right, what else can we do? So we did a little bit with service discovery. One of the things that we can do is we can wire up some health checks so that these services don't need to just be alive. They actually need to pass all of the health checks that we might put into them later. So for example, the API service might need to initialize the database or things like that, however you wire it up. You can see at the moment if we go in, there's a section for it, but there's nothing there, and that's quite easy. So health checks are already in there because we added them with service defaults, so we can just configure them within our app host. So if I bring this up, we can say with HTTP health checks and /health. I'm going to do the same thing for the API service. It's got health checks too. And that'll about do it. We don't really need to run that, but you'll see when we do, it doesn't just wait for the application to be live, the service to be live. It waits until it reports back healthy from those health checks. So you could see the web took a little bit longer to start up and didn't bother starting up until it knew that API service was ready to go. So that's good. All right. So Aspire ships with ready-made integrations, so you don't have to wire everything by hand. And these integrations cover the core services that every distributed system needs, such as databases and storage, messaging, caching, and observability. Now, an Aspire integration is a ready-made building block that wires up all of the common services for you. So with health checks, telemetry, and smart defaults already included. And as you can see from these examples, Aspire supports a wide range of integrations. Now, right now, our demo app is running on SQLite, but it's time to level that up. So I want you to take out your phone and let's swap out the database using an Aspire integration, and I'll let you choose which database we go with. Okay, that's all right. If that's the only demo failure we have tonight, I will be happy. Welcome to Slido, log in, sign up, it's free. Oh, that's really giving me a hard time. One sec. Otherwise, we're just going to have to do it via noise. Slido. Come on. Okay, I'm signed in there. All right, we'll try restarting PowerPoint. Bear with me. I expect a lot of failures tonight, but I didn't expect this failure.
That's one of the few that's not handled by Aspire.
Yeah, that's right. No health checks, no orchestration. Okay. Yada, yada, yada. Slido. Yay. Okay, scan the QR code. Tell me which database we should use tonight, And we'll use that database for our demonstration. Now, obviously, Aspire supports many more integrations, but these are the two that I've prepared demos for. All right, votes coming in. It's going to be Postgres. No, Azure SQL. Azure SQL's got some votes. That's nice. Oh, wow. Azure SQL spinning to the top. Look at that. Oh, hang on. Oh, it's a race. Okay. Looks like it's going to be Postgres. Okay. Oh, Azure SQL's creeping back up.
Make a fake account.
Anyone else left? Might be some people online as well. All right. It looks like PostgreSQL is our winner tonight. Okay. Let's do it. So let's see how easy it is to wire up PostgreSQL with Aspire integrations. Okay, back over here, stop this. All right, so of course the first step is to download Docker, figure out which container to use, spin that container up, make sure we've got all the, no wait, we can use Aspire integrations, right? It's gotta be easier. So let's go to app host. And the first thing we want to do is model this resource, right? A PostgreSQL database. So I will try to right click and go add. And this time we're going to add a .NET Aspire package. And we're looking for Postgres. And I want to run it on Azure. Let's try that again. So I'm going to use this one. Not that one. Yes, that one. There we go. That was hard. Okay. I accept everything. And back to our app host. So, make this bigger. We've got our API service, we've got our web service, and now we're going to have a database server. So as developers, and for myself as a C# developer, it's pretty nice to be able to define these resources in code. So I'm going to say builder dot, we'll drop it down, dot add Postgres flexible server, and we'll give it a name. SQL sounds good, and we'll say run with passwordless authentication. It does also support managed identity, but I haven't got that story to work with all the different combinations. So that's something that I need to look into a bit, but it works with password authentication. Run as container, and we want our container lifetime to be persistent. And that's nice for our development environment because it means that each time the application starts, run as container, I did that wrong. Each time the application starts, it doesn't have to keep spinning up that container from scratch. It'll be there waiting for us. Okay, there we go. So we have a database server, and if we were to run that now, it would spin up a database server, and you would see it on the Aspire dashboard, but we're not quite ready yet. Let's also create a database. Now, what do I call that? I call it database. So database server dot add database. I'm going to call it effortless. That's pretty good, but we're not doing that. Add database effortless DB, and that'll be fine. And then we want to actually state, let me see, we want to state that the API service is dependent on that. So first we'll say, hey, you know what? Oh, that looks pretty good. Wait for database and with reference to database. And so that means that service discovery is going to populate that connection strings for us. We'll have an easier time there as well.
With references?
Mm-hmm. Yeah. With reference injects service discovery information. In this case, injects a connection string as an environment variable. So let's see. So now we have to update the API service, right? And that's in not print, program for the API service. And what we have here at the moment is we grab a connection string and then we add a DB context of type SQLite, and that connection string's in app settings. What we need to do is bring in an Aspire integration, but this time instead of a hosting integration, we're going to bring in the client package for Postgres. So if I right click on this API service and go add, and we're going to add an Aspire package again, and if I search for Postgres, maybe entity, because I'm going to bring in the Aspire integration that supports PostgreSQL for Entity Framework Core. And the reason that we're doing that is because these integrations have all of these smart defaults, right? Open telemetry, logging, and also helper code. So to make it really easy for us to wire up Postgres with Entity Framework Core. And you'll see what I mean when I delete all of this code and we just say builder.add npg db context, and we say the context name is effortless db, and that is it usually. What did I do wrong there? Hang on. Add npg connection name.
Is it possible to pass like the service discoverability, the discovered information here from the database service?
From the database service to here.
To here, so that's like, so the database.
Yeah, you can pass configuration.
Knows what database it created, and it passes this information.
Oh, that's the one.
DB context initialization of the service. Here is your DB.
Mm-hmm. We kind of have done that. So when we say effortless DB, it's going to look out at the environment variables and actually grab a connection string for that specific database server and database. So there we go. It took me a little while. Add Azure npg SQL DB context. The DB context is app DB context, and the connection name is effortless DB. Now the other thing that we can do now is we don't need these connection strings. Where's my connection string? Well, that's app host. We don't need connection strings here anymore. That'll be managed via service discovery, and we don't need all this SQLite mess. There is an integration for SQLite with Aspire as well. So, if you know and love it, you can use it. All right, where are we up to? So we've added the DB context, we've deleted the connection string. We can run it. So pressing F5, we're expecting Aspire to spin up that Postgres container. So we don't have to go and install anything locally. Aspire is just going to spin it up for us. You can see the API service is waiting for the database, and web is waiting for the API service, and we've got this whole nice mess starting to form over here. So we can try to untangle it if we like while we're waiting. There we go, that's looking a little bit better. Back over here. And apologies, it does take a little while on my system, just because it's a laptop. It's not quite as fast on my laptop as it is on my home PC, but they're spinning up, and it failed. Okay, so I forgot to do one thing. I've got some migrations for Postgres that I prepared earlier, so let's go and fix that up. Trying to do everything as quickly as possible tonight because there's a lot to cover. So open folder in File Explorer, drop back a couple of directories, migrations, PostgreSQL, back, there it is. Delete the SQLite migrations, whack those ones in. I shouldn't have stopped it. I didn't need to stop it. We could have just let it fail and then gone and press play on the Aspire dashboard once we had brought those migrations in. So that should work now. There we go. API service came up. Web's come up. We can click on that. We can go to our bug report. We can submit a bug. And then that went off to PostgreSQL. We can have a look at it. Since there's no way to see that, we can have a look in the console. And there should be, yeah, there it is, insert into bugs. So we got a bug inserted there. All right, so that's it. That was really quick, right? That's from SQLite to PostgreSQL. We could have done the same with Azure SQL or any other supported database. So good. I might take the chaos out of the application now. We won't need that anymore. So that's just a little bit of middleware that I threw in there. Where is it? Up here a bit. There we go. Yeah, 70% of the time it'll succeed. All right, back over here. Okay, I wanted to give you a recap, and that's it. So with minimal effort, we've integrated a database with health checks, connection strings, telemetry, already configured. Aspire has removed quite a lot of the friction so that we can focus on building features. Now, of course, databases are only one piece of the puzzle. The bigger challenge is reliable communication between services, because even with all of that smart defaults, the reliability that we built in, if API service isn't running, bug report's not going to get submitted. It doesn't matter how many times it's retried. And so this is where messaging comes in. So we leverage messaging with services to communicate reliably at scale without this tight coupling. So messaging essentials, here's what makes messaging so powerful in distributed systems. Messaging ensures reliable communication between services, and messages don't get lost, right? They're delivered with durability and retries. It decouples services so they can evolve at scale independently. And it gives us graceful failure handling. If something goes wrong, messages wait safely and can be retried until the system recovers. And that's exactly what we'd like to do with our example tonight, is just make sure that if a customer submits a bug report, because our system's pretty buggy, that it gets stored and is eventually going to make its way to us. Here's a simple example. So in this example, service A sends a request and then forgets about it, right? It moves on, but the message bus stores it in a queue. When service B is ready, when it's available, when it's alive, when it's not overloaded, it takes the request, does the work, and replies using the same approach. So the queues are like inboxes. There's no waiting on live connections. The messages wait safely, and the system can retry if something fails. And this combination keeps the services decoupled and resilient. So we're going to start small. We'll add messaging with nService Bus. nService Bus is a product provided by particular software. You may have other message buses that you like to use, such as Mass Transit or Wolverine or Brighter. This is just the one that I know the best. And we can use nService Bus with the learning transport, which means that we don't need to install any infrastructure, and we can get things up and running without worrying about the complexity just yet. So let's have a look at how we can do that. Bit of a cleanup. All right. So we know that if we were to run our application and the API service is offline, it won't matter what we do, that bug report will not be submitted. So let's see. We can start by, let's start by just adding messaging to effortless.web. And I can do that by bringing in the nService Bus hosting package. So I'll manage NuGet packages, browse nService Bus extensions.hosting. That's the one, and we'll install that. And now what I need to do is to add an endpoint to the web project, and we'll do that just here. And I won't type out all that code, but I'll explain it. Let me make this bigger too. Okay, so, too many comments. So we've got an endpoint configuration that's going to be called web endpoint. So any requests for our web service will come in via here. We're going to use serialization system JSON, and the endpoint configuration transport will be the learning transport. This is just an easy way to get started. It stores requests on disk in a file. And then we wire up with use nService Bus endpoint configuration, which will get that all wired up and started for us. Very easy. Now, next we need to change our bug report. So the bug report is a Blazor Server Razor component, and at the moment we're injecting the API client and submitting the bug request to the API backend, which immediately inserts it into the database. We won't do that anymore. We'll inject an iMessage session, which is a simple class for simple messaging from nServiceBus. And we come down here, we can actually delete most of this code. We'll do it in steps. So we'll say await message session dot send, and we're going to send it to the API service, and we're going to say pass the request. And the request is the create bug request, right? The form that I've been filling out. And so once that's done, we're going to just show success. We're going to new up the request form. We don't have to worry about these error handling anymore because it's pretty reliable. No network involved there. So,
without chaos middleware.
yeah, without the chaos middleware, it's super reliable. 100% of the time. Okay, I think that's good. No, there is one last thing we need to do. So this create bug request, we just need to mark it with a special class from the nServiceBus message interfaces package. So I'll install that. So manage NuGet packages, nServiceBus message interfaces, and I accept. Okay, so where did it go? It's here. Okay, so this is an iMessage, and this is just an empty marker class that just tells nServiceBus this is one of the message types that's going to be flying around the system. Let's see, I think that's good. Okay, let's run it. Let's run it and see what happens, make sure that we're on track. And then if that's all working well, then we'll move over to the API service and start actually handling these messages. Give it a second. Yep, bug report, test, whoops, test. We'll do multiple tests. One, just to be sure, right? Always test first. Is this what they meant? Maybe not. There we go. It's working, right? So these messages are being added to a queue in the learning transport, and they're waiting for something to pick them up. We've sent them to the API service. We haven't created that endpoint, so let's create that endpoint. And we're doing it in the same way, right? So instead of installing a package, I think this will be quicker. I'll grab that package there. I'll put it in here. This is friction, right? We're starting to have to do some of the same things across multiple parts of our application. And whenever we encounter this friction, we should be thinking, I wonder if there's an easier way. What if it could be easier? What else could we do here? Think about that. Something didn't work. Packages. Wait. Endpoint configuration. What is going on? Let me see that again. Packages. Say again?
Is there an nServiceBus client package the same way there was for?
Not at this stage, but I'll show you how to simplify some of this. Why is it doing that? Yeah, I see that. I just wondered, it didn't import anything here. It's just conflicting. Let me see. API endpoint. It's funny how.
Using Microsoft Server Orchestration laptop.
Yeah. Is it using that? Am I in the right package?
Yeah,
program? Yeah. Did you say line 4? Yeah, I could try deleting it. Let's do a build. It might have, I know what happens, yeah, thank you. When you paste it in, sometimes it tries to insert the using statements for you, import the right namespaces. And all day today and yesterday and Tuesday and Monday, it's been importing the right namespaces. And tonight, Kestrel. That's okay. All right, so we've configured an endpoint. The only difference here is it's an API endpoint. It's still using JSON. They're going to communicate using JSON via the learning transport. Now, the only other thing we need is a handler for this message type. So I'm going to create a folder called handlers, and inside of that I'm going to say a create, I'll put a create bug request handler, and that's there, and then we'll paste in the code that I created earlier, which is here, and you can see that it just basically takes this create bug request message and it news up a bug, the entity, and then it adds it to the bugs table, and then it saves the changes. So I've just put a little breakpoint on there, just so that we can see that it's working okay. I'll press F5, we'll wait for the application to spin up, and we can give it another test. So API service is spinning up. Fingers crossed. It's ready. Web's spinning up. Good. Let me see. I think that's good, but I did expect it to hit this breakpoint. Makes me think that maybe I've configured something incorrectly. So there's an API endpoint, and then in our bug report, we've put API service. So, whoops. So that needs to be API endpoint. We can create a shared project later on and use constants for this sort of stuff so that we don't run into that kind of trouble. So let's fix that.
Where did the messages go earlier?
They're in the queue called API service that no one will ever pick up. But that's okay because they're bug reports that we're not going to look at anyway. It doesn't really matter where they go. No, they're being managed by the N service bus learning transport. So the messages are not in Postgres, they're on file, on disk. The learning transport is a kind of just a good tool for demonstrations and trying things out. But we'll switch away from that. So if I go test,
It's not the transport that's learning, right? It's the messages. It's you who's learning.
submit. There we go. So you can see that was quite quick. It came through here. And is now submitting bugs. So all good there. So now what's interesting is, of course, if I just press F5 here, get that bug inserted. If we stop the API service, it's decoupled, right? So I can still go ahead and submit as many bug reports as I want. And when that API service comes back up again, it's going to start processing them. Okay, they're there waiting. So those messages aren't being lost anymore. So both of those messages that I just submitted came through. And you can see that was really easy, right? But let's make it easier. Let's just do a little bit of refactoring, right? So we know that we want to use the learning transport at this stage, and we know that we want our endpoints to communicate via JSON. So let's just make that helper code so we don't have to write that every time, because it's a small system now, but it won't always be. So we'll add it in service defaults. We've already got a project for it. And we'll use some code I created earlier. Now I do need to bring the hostings package across, but that means that I can actually remove it from the API service and only reference it in service defaults now, because web and API both reference the service defaults package. There we go. And that will hopefully, there'll be a Kestrel thing again. Back up the top we go. Kestrel, there we go. Make this bigger. Okay, there we go. So we have an extension method called add messaging endpoint, and all we need to do is pass the endpoint name. So let's refactor a little bit. So we'll go to program. This is the API service, and we go delete. Actually, I'll copy that because I love to copy and paste. Delete all of this. And we can just say builder.add messaging endpoint called API endpoint. And now we want to do the same thing for web, right? Program web, just different name. So this will be our web endpoint. There we go. Okay, so we've reduced a little bit of the friction, right? So as I said, when you find friction on your journey local dev to cloud, try to eliminate it, try to find an easier way. And sometimes that's as easy as refactoring, sometimes it's about choosing the right tool. Okay, let's see. I think we're good. I'll give it a quick run. Running. Good. And another bug report that no one will ever see. And submit. Oh, we hit our breakpoint. We'll take our breakpoint off now. Oh no, we'll leave it on. We're going to do a little bit more with that. Okay, good. All right, so now we have messaging running locally without the need for infrastructure. However, we can use the same code patterns that we've just set up to move to a real message bus. So we could use Azure Service Bus, or we could use RabbitMQ.
What is it using as the transport for that when you didn't add messaging endpoint?
It's still using, I'm sorry, I didn't make that clear. It's still using, so what is the transport that it's using when we do the add messaging endpoint? It's still using the learning transport right now.
Okay,
Yeah.
So that's your extension method, add messaging.
Yeah, this is my extension method. I've just made it a little bit more abstract, and I've encapsulated these choices in this extension method. So anywhere I want to wire up an endpoint using this approach, I can just call it and pass the name. But we might want to use Azure Service Bus or RabbitMQ, right? So I'll leave that up to you. Which message bus should we use? Azure Service Bus or RabbitMQ? I think I know which one is going to be the winner here. I was pretty sure that it was going to be Postgres, but I'm not going to influence the decision because I want to see how it turns out. All right, looks like RabbitMQ is off to a very strong start. Wow. Got a little bit of movement from Azure Service Bus.
Does Service Bus have an emulator now?
An emulator, it does, yes. And if you vote for it, you'll see it. I'm not sure on how many queues it's limited to, but it does have some limitations around automation, such as automatically creating queues and things like that, which makes it a bit tricky to work with. But, you know, one of the interesting things about Aspire and some of these Azure integrations that you can use, you have the choice, right? You can have it spin up a version in Docker, or you can have it connect to something in Azure, or you can actually have it spin up something in Azure for you and connect to that. So there's a lot of opportunities here. Tonight I'm focusing on everything with Docker and what I can do locally, but there are other options there. So while the Azure Service Bus emulator has limitations, it's not the only option. All right, so it looks like RabbitMQ won by a large, oh, look at Azure Service Bus jumping up then, by a large margin. So the winner is RabbitMQ. So in the next demo, we'll switch from the learning transport to the RabbitMQ transport. Okay, so we have this nice little bit of helper code here that we can work with to do that, but first we'll need to install the transport. And so we'll only be doing that in one project now, of course, so that's add, wait, I always go add, but I need to manage NuGet packages. Right click, manage NuGet packages, browse, and Service Bus. Is that going to work? Probably not. Service Bus, RabbitMQ. There we go. Install. I accept. Okay. So the first thing we'll do, now that we've got that done, is we will go and prepare our RabbitMQ resource. And we'll do that within app host, right? This is where we define our resources and their dependencies. So we'll call it messaging, and it's going to be builder.add rabbit. Didn't work. Because I installed I installed the right thing at the wrong time. We've got to install the Aspire integration first. So we go to .NET Aspire package, and you can see this is bringing up, well, you probably can't see. Hang on, let's zoom in. Well, you can see that it's bringing up the Aspire integration hosting packages, whereas if we do it on API service or the web project, it'll bring up the client integration packages. Okay, so we want RabbitMQ. There it is. We will add that. Zoom back out. I accept. And now we can define it. Add RabbitMQ. We'll give it the name messaging, which is how we'll refer to it in regards to service discovery. And now the service bus RabbitMQ transport uses the management plugin. We don't really have to jump through hoops to install that, because we can just say use management plugin, and we'll specify the default port. Otherwise, Aspire will generate one, and we'll say with lifetime, and it's container lifetime persistent. So hopefully we don't have to wait around every time we launch the application, because the container will already be running. Now, both of our services will be dependent on RabbitMQ, so we can just say wait for, it had it right? No, I typed it wrong. Wait for messaging with reference messaging, Control-C, Control-V, there we go. So now they'll both wait for messaging. And now all we need to do is to wire up the transport. So I've already installed the package for it, so we're a little bit ahead there, which is good. And so we're not going to use the learning transport anymore. We'll still use JSON serialization, because it's the serialization that was named after me. And we'll say, we need the connection string first, right? Connection string equals builder.configuration.getConnection string. Not quite, messaging, because that's what we named it. And if we can't get the connection string, then just explode. There we go. All right. And so now we'll go endpoint configuration.use transport. We could do it that way. We'll do it this way. New RabbitMQ transport. And we specify our routing topology. And we're going to use conventional with qtype, qtype dot, hang on, quorum. And then we're going to pass in the connection string. I put in too many brackets. Connection string. I pressed the wrong button. One sec. Good. Okay, let's clean this up. Connection string. There we go. Okay, and one cool feature, we'll use endpoint configuration to enable installers, which essentially means that N-Service Bus will go ahead and auto-create the queues that we need, such as the API endpoint queue and the web endpoint queue. I think that is all we need. Let me see. Got my notes. Let's try it out. Okay, so it's going to take a little while for RabbitMQ to spin up, but we'll see that happening. There we go, messaging. Where's Docker? We've got a whole bunch of stuff there. I should clean this up. It's not too bad. Starting. So SQL or PostgreSQL is already running because it doesn't have any dependencies. Messaging is starting up. Of course, we can look in the console and see what's happening if we like as it starts up. Now that's running. Now API service will start up because its dependent resources have been satisfied. And patient, good. Web will start up. There we go. All right. So now we've got messaging using RabbitMQ, and it's working nice and fast. All right. So that wasn't too bad. We defined, well, let's go to the slides. So we added RabbitMQ using an Aspire integration, and then replaced the end-service bus transport with minimal effort. Aspire handled orchestration and service discovery, and then service bus kept the same messaging semantics. So it was nice and easy. But of course, there's one last challenge to solve, and that's moving from local development to cloud. Okay, in this section, we'll use the right tooling to provision resources in Azure, deploy our services, and we'll do it all using a nice, consistent workflow. So .NET Aspire apps are flexible. The same app can be run locally on your development environment, or in containers, or in the cloud. When you're ready to deploy, Aspire creates a deployment manifest, which describes the services and resources that your application will need. And we can use that manifest with tools such as the Azure Developer CLI, right? And the Azure Developer CLI can read that manifest, provision the infrastructure, package the application, and deploy it to the cloud. And maybe you've seen me talk about Azure Developer CLI in the past, and I will use it, and I will grab a template, and we modify some bicep, and we push it up. We're not going to do any of that tonight because the deployment manifest describes those resources that our application needs. And that's what's really cool about Aspire. It's bridging that gap. We have an app model. We've defined it in code. We've defined it in C#, which we know and love. AZD is going to, well, Aspire is going to generate the deployment manifest. AZD is going to read that, and it knows what to provision because we've told it. Now, I've just covered the basics here in that app model, but we can go into much further detail. We can say, hey, we want to use Azure Container Apps. We want to use Application Insights. We want to use Log Analytics. We want to use this SKU for our Postgres SQL flexible server that's running on Azure. Okay, we can define all of those things there. So I'm hoping that in terms of effortless distributed computing and our journey from code to cloud, we won't have to spend too much time in the future working with tools like Bicep and Terraform. They'll still be there behind the scenes, and we can use them if we choose to, but there might be an easier path for many of the applications that we build and for many of the developers out there. So we'll use the AZD to provision these resources to the cloud. And of course, with the same tool, we can also configure some CI/CD pipelines so that the whole process becomes repeated and becomes automated and repeatable. But I'll leave it up to you. Which deployment pipeline should we use tonight? We can either use Azure pipelines and GitHub Actions. I know which one this way will go to. I know which way this one will go as well. But let's see.
Is that a challenge?
Yes, JK, it's a challenge. Wow. Okay, I am shocked.
We're not all in yet.
Yeah, come on, hurry up. I'm sorry that I issued a challenge. No, either way is good.
Question. People choosing one, have you tried the other?
Look at this. I did not know it would go that way, but I live in my own little bubble. That's.
So you guessed the other two right.
I guess the other two. Yeah, this one was a surprise, but there's still time. Get your votes in.
An hour and still waiting.
Yeah.
Just forcing everyone to wait.
Yeah. It's actually not that big a deal because we can. We're going to kick it off, but we're not going to wait around to see it finish. So.
It's your talk. You can deliver whatever you want, right?
Oh, that's right. It looks like. Not there yet. 50-50. Well, there we go. Azure pipelines.
One more coming.
Here we go. Back to 50-50. Okay. Oh, look at that. Oh, wow. Okay. Here we go. Man, this is getting competitive. I didn't expect that. Look at that.
I think people are just messing with you.
Wow. Okay. Looks like. Okay. It looks like GitHub Actions is the winner. Or is it Azure Pipeline? All right. We're going to go with. Dang. Okay. I'm going to go with Azure Pipelines. It's fine. It's fine. We can do it. All right. Let's see it in action. We'll take our demo app. We'll use AZD and we'll set it up using Azure Pipelines. Okay. So let's see. We don't need to do too much in here. We're going to jump out to the command prompt now. So the first command that we run is azd init, and so it's initializing an app to run on Azure. And what it really means is it's going to set up the necessary configuration for AZD to know how this application is built, what services it has, and how it can deploy it to the cloud. Now I can of course select a template and build from that, or I can scan the current directory. And so this is where it's going to use that deployment manifest, look at what this app needs, and actually figure it out for us. So I'll give it a second. Now this is a feature that's being worked on by the Aspire team. They're really focused on the development, on the deployment story. So I'm hoping to see lots of great things coming over the next year. So we have the choice. It's detected that it's an Aspire project. That's good. It's going to we can either confirm and continue initializing the app, or we can cancel and exit. So we'll confirm. And we need to give it a unique name. So I'll give it briz.net dev. And that's it. So now it's given us a whole bunch of information. It's basically said I've generated an Azure YAML file, and that is essentially an AZD configuration file or metadata file that describes our apps and where they're located and how they can be built. And it's also generated a next steps.markdown document. We can jump into that and learn all about AZD and how it works and how we can work with it in the context of this application. You can see it's also given us some commands that we can run. We can run AZD up, and that will package, provision, and deploy our application to the cloud. We can run AZD add to add new Azure components to the project, and we can also run AZD infra-gen if we would actually like to generate all of that bicep based on the deployment manifest, and then take control of it from there, which is a really good option, right? You have that fine-grained control if you want. But I want to take the app model, the Aspire app model, as far as I can in code before I start playing with the bicep, because I can see that that is definitely the path with least friction. But there are lots of other commands with AZD. This is not an AZD talk, but you can also look at AZD provision. Once your application is up and running in the cloud and you make some changes to the infrastructure, you can run AZD provision to get those changes in sync. If you've made some changes to the API service, you can run AZD deploy, and you can target just the API service and just push a new version of that up. You can run AZD monitor to launch the dashboard quickly with Aspire and a deployment to Azure Container Apps, which will be the default that it's using right now. When you run AZD Monitor, it actually brings up that Aspire dashboard running in the cloud in the container. So you get access to that as well. What else is there? Well, there's my favorite command. There's AZD pipeline config. And so with AZD pipeline config, it's basically this whole workflow that's going to set up everything for us. And today, we won't be using GitHub, we'll be using AZDO, so Azure DevOps or Azure Pipelines to deploy our application. And you know what? This is the thing that I meant to test today that I didn't think would actually happen. So this is probably where we're going to have the biggest failure. So GitHub works well. It's out of my hands. I called the vote. Let's see. So analyzing the Aspire application, initializing the bicep provider, choose a subscription, choose a location. We'll go with Australia East. There we go. And now it says, hey, you know what? You want to deploy with Azure pipelines, but you haven't built a pipeline. How about we give you one? So here's an Azure dev.yaml file with an Azure pipelines as code, which is where you want it, right? Because then you can evolve your pipeline over time. You can check it into source control. You can see how it changes. If someone breaks something, you can blame them. It's good. So would you like to add it now? Do you want a free pipeline? Yes. There we go. Fail. Pre-config check error from Azure DevOps provider. Azure DevOps does not support federated authentication. That's fair. We have to use client credentials. That's okay. Client credentials flag. Let's try that again. Fingers crossed. It should remember the subscription that we've chosen and the Azure location that we've chosen. Personal access token. Seriously. All right, no, we'll switch. My apologies. I'm not ready for the Azure DevOps pipeline demo. I'm going to bow out and switch to GitHub because it's just so much easier. I haven't created a personal access token in about 2 years. All right, so you get to see GitHub. Here we go. Fingers crossed. But now we might have to clean up that pipeline. I better just delete it, huh? We'll just delete it really quickly. Because it created, I'll show you. Oh no, it's okay, it's okay. So it creates the Azure DevOps pipeline here in the AZDO directory. So that's fine. It wasn't going to conflict. Let's try again. I'm sorry for those of you who voted for Azure pipelines. Yes, question.
In the app host, can you mark certain resources to be just for your local and not in the deployed environment?
Yes, you can. So the question was, in the app host, can you mark certain resources just to be for your local environment and not necessarily the deployed environment? Yes, you can do it both ways. So I could check to see if we're publishing in the app host, and I could say, okay, now I want. Let's continue with this. Would you like to add it now? So add the pipeline for free. Yes, please. So I can say, if we're publishing, I want application insights and I want log analytics, or I want you to pass an environment variable to my app service that's the ASP.NET Core environment variable to tell it its development or staging or production, those sort of things. Yeah, so you can have that control. So now it says, so you want to set up a GitHub CI/CD pipeline and you don't even have a repository. Do you want us to create one for you? So yes, please. What do you want to name it? We'll call it briz.net dev, and it'll go off and create that repository for me. Because when you install AZD, it actually will choose federated service principal. It actually also installs the GitHub CLI. So it's using the GitHub CLI to do some of these things with GitHub. And so now what it's doing is all of the things that we used to have to do manually, right? So it's gone off to Azure. It's created the service principal, an identity for the app so that GitHub can communicate securely with Azure. It's also created federated credentials to use for that communication. You can see it there. And it's actually then setting all of these repository pipeline variables in GitHub that it will need to run the pipeline. And so then it says, would you like to commit and push your local changes to start the configured CI/CD pipeline? We say yes. And then it asks me for my passphrase for my security so that I get that nice verified commits. I think I know it.
Hang on, we can't see.
It's ...
Hunter 2.
Fingers crossed. I think I typed it in right. Yes, okay. So that's done. So if we go GitHub browse, Using the GitHub CLI, we come to our new briz.net repo. And if we switch over to actions, we can see our new Azure Dev workflow has kicked off. And if we come into here, we can see what it's doing. So it's installed AZD. It's going to use AZD to package, provision, and deploy the application. And right now it's provisioning infrastructure, okay? And that's going to take a little while. It's going to take about 10 minutes to get through all of that. And then it'll deploy the application. Once that's finished, if I make changes to my application to deploy those, they get published in about 1 minute. So it's nice and quick after that. But what we have now is a CI/CD pipeline which has automated this whole process to put it into the cloud to our first environment. And we can change this pipeline later in code to extend it out to the other environments that we'd like to have. So this is certainly the easiest path to getting started.
RabbitMQ and like for that environment, is it creating a new environment in Azure?
Yeah, it is, yeah. Yeah, let's have a quick look.
Does it create all the GitHub secrets as well?
Mm-hmm. Yeah. Yeah. Let me show you. Yeah, I'll show you. I'll show you the secrets. So if we go into settings, and we go into, there's nothing actually that secret here. You've already seen my subscription ID. So yeah, you can see we've got client IDs for our service principal, our location, our SQL username, our Azure subscription ID, tenant ID. So we don't have to do that anymore, right? To set up Azure, those credentials, this workflow, these variables, these secrets, we have tools that can make that journey effortless. Unless you need a PAT token, then yeah. Thank you. Okay, so if we come down here to resource groups and I correct my filter. Okay, so there's our Brisbane.net stuff coming in, and that'll take a little while. But of course I got one that we created earlier, and it's effortless dev. And this one, I think it's all good to go. So look at this. If I go and click on the container apps environment, if you want to see the Aspire dashboard, once you've deployed to Azure Container Apps, you have to go in and configure access control. You can check that out in the docs, but then you can just go open dashboard. Now this is just storing, if it works, this is just storing stuff in memory, right? So it's not a replacement for something like Application Insights, but it is sure handy for us as developers to be able to have this tool in the cloud ready to use. And I had to be authenticated to access this tool, right? So it was, I'm signed into Azure, I can access the portal, I have the right role for this Container Apps environment. That means that I can access this dashboard. So if I click on this web URL, I can see my apps running. I can get as many weather forecasts as I like most of the time, and I can still submit bugs. There we go.
Which database backend was supposed to win?
That one was, that one that I just did, which database backend, that was Azure SQL, running on Azure Service Bus, deployed through GitHub Actions. So at least I know now I need a PAT token. All right. Okay, and that's it. A couple of commands, AZD init and AZD pipeline config. We've gone from local development to a cloud-ready deployment, and we've got the same workflow that runs on my laptop running in the cloud and integrates directly with CI/CD pipelines. And that's how Aspire and AZD make the local dev to cloud journey effortless. And that's everything I have to share with you today. However, if you'd like to go deeper, I've got this QR code, which gives you 90 days of free access to the Distributed Systems Design Fundamentals course, which includes 11 hours of content with hands-on examples. Feel free to give it a spin and tell me how it goes. I've also got some swag over there if you're interested in learning about the distributed system fallacies. There's some books over there, there's some particular footballs, and a whole bunch of stickers if you like to decorate your laptop or your fridge or your car, whatever you like. Give me a moment to scan that code.
So just a follow-up question on that.
Yes.
Resource thing.
Yes.
Is to say that you don't want it, say, deployed or something.
Yes.
Is it similar like with command?
Would you like to see an example?
Yeah, that'd be cool.
Okay, let's do it. So, in our app host, I'll make this bigger, and on my cheat sheet, I'll expand my bonus content, and we'll do this one. So I haven't installed the integrations right for this, but you can see. So if I go ahead and install the Aspire integration for application insights, it will then create a log analytics workspace. It will create a application insights resource, and we can reference the API service with insights, and we can reference the web service with insights. And then the only thing that we would have to do is jump into service defaults. Was that? No, it's the extensions file, extensions. And we just scroll down, no, up from here. Here, uncomment the following lines to enable the Azure Monitor exporter. And so that means that at that stage, both web and the API service will be reporting to application insights using OpenTelemetry.
It's all OpenTelemetry. There's a lot of tooling for OpenTelemetry that's ingested.
Yeah, and I need to install another package there as well. Which one was that? That was the Azure Monitor OpenTelemetry ASP.NET Core package. Anyway, if you're interested in seeing how that works, feel free to message me, and I can share the details. All right. So today we've seen how Aspire and Service Bus and the Azure Developer CLI work together to make distributed systems development feel effortless from local development all the way to the cloud. Now, whatever your journey is, whether it includes these tools or not, I encourage you, as you're moving along the path from local development to the cloud, to look for those bends in the road, to look for that rubble on the footpath, and think, what if there was an easier way? What if I could make this easier and make your journey as effortless as possible? I hope you're inspired to try some of what you've seen tonight out, and I'd be excited to hear what you build. If you'd like to stay connected, you can reach me on connect.jasontaylor.dev. Thank you.
Thank you very much, Jason.
Welcome.
Jason will be around after this. If you have any questions, come up and have a chat. He's always got a lot of info to share. So we do have some giveaways.
Yes.
Did you have any questions you particularly liked?
Let's ask this question, because sometimes it's a bit tricky. Would anyone like a JetBrains subscription that does not have a JetBrains subscription?
It's a single product license, so you can pick any of their products and try out one of them. They've got some very handy ones. I use Data Grip all the time, which I think is my favourite of theirs, but obviously there's Rider, WebStorm, a whole range of different things if you want to try any of them.
We have it right here. Yes?
Cool.
Sure. We have two. Would anyone else like one?
Thanks, man. Sweet.
Yes. Thanks for coming tonight.
Thank you.
There we go. All right. So, before we wrap up, is there any other questions, JK?
Yeah, how do you update the YAML file for and all of the other deployment stuff when you make infrastructure changes?
How do you update the YAML file for the pipelines as code?
Yeah.
Or for, so you just go in and edit it just as you would with any other pipeline.
But what if you change it in .NET Aspire and you make some changes? Can you reflect that?
Yes. So what if you change it in .NET Aspire, what if you change the code-based app model in .NET Aspire? Does it reflect those changes? Yes, because at the moment we haven't generated the infrastructure files, so it's going to keep looking at that, building that deployment manifest, and then the pipeline that we've established is just doing three things. It's actually just packaging the application, provisioning the resources based on that manifest. It generates the bicep on the fly, and then pushing that app out to the cloud. So you don't have to do anything. Later on, if you do run AZD, I think it's AZD infra gen, and generate out those bicep files and take control of it, what you could do is evolve those bicep files to be whatever your needs are. You can change that app model, make sure that you've got a clean commit space, and then run AZD infra gen again and see what changes it makes, and then kind of merge them back in together so you could bring them back in sync if you wanted to.
Pipeline do a tidy up, as in if you did PostgreSQL and then you want to do Azure SQLite or something.
Yes.
You've run it, you deployed it, then you said, oh, it's costing me too much for Postgres, I want to go back to SQLite.
Yes.
When you do the redeployment, does it magically get rid of that provisioned resource?
No.
Yeah, that's what
No.
I said, it's just the tidy up. Yeah.
Yeah. It will maintain the configuration of the resources that you provisioned, but if you remove that resource, it won't go and delete it from Azure by default. Yes?
So does Aspire serves as like the service discovery machine, but does it provide any reverse proxy or like ingress controller functions so that you can access different services through a single endpoint? Like other than the developer dashboard, so you access something and it routes things like similar to YARP or something?
I have no idea. I'm sorry. Excellent question. But yeah, no idea.
You can add YARP in Aspire as a result.
Oh yes, I did see. Yeah.
Yeah,
Thanks,
but
Luke.
that kind of well defeats the purpose of service discovery.
Yeah.
Or like you
So-
have to configure YARP
Yeah.
through the Aspire configuration, read that and feed YARP configuration with it.
Okay. All right. Last question.
If you use something like Key Vault,
Yes.
will it automatically create keys?
Yes, it does. Given the right Aspire integration or the right bicep files that you've generated. So I've seen it generate Key Vault when I've supplied, what did I do? I supplied a specific username and password to RabbitMQ. And yeah, it generated a Key Vault, it generated the keys, and it linked up the containers with access to it. So it was all good. All right. Thanks, everyone. Night.
Thank you very much, Jason. Another big thank you to Microsoft for allowing us to be in here tonight, and Particular Software for sponsoring the pizzas and providing us with Jason for the evening. Also like to thank my fellow co-host, Todd, who does most of the work behind the scenes. I'm just the pretty face at the front. And Cam, who helps us getting things running, and Dan, who's come on as a co-organiser to help us with organising the space, the Microsoft and everything like that. So big thank you to those guys as well. If you do have any ideas for a topic or a talk, please reach out to us through Meetup. If you want to sponsor an event and get up and speak a little bit about your business, or you're looking for people, do reach out as well. Please join us next month as we were talking. The topic is, sorry, I giggle a little bit, modernising a 17th century Italian English dictionary by Wayne Sebens or Sevens. It doesn't sound like an IT focused talk, but he's talking about doing it using with .NET and a custom vector embedding model, and then orchestrating it all with Aspire again. So there'll be more Aspire content next month as well. So once again, come along, first Thursday of the month, first Thursday of November, right here as well. And I will see you all then. Thank you.
Thank you.